So this question, find the coordinates of the vertices for square A, B, C, and D, and the equation of the diagonals. What we are given in this question are the coordinates of two of the points, A and C, two opposite points, as 7,2 and 1,4. What we are asked to find out are the location of the point B and C, or the coordinates, and if we know them, then we can also figure out the equation of the lines AC and BD, and so on and so forth. In fact, if you want to proceed a bit more into the details of this, you can also end up finding the equation of the sides, AD, BA, CB, and CD, something like that. So basically every detail can be worked out, every single detail of this square can be worked out just by knowing the coordinates of the opposite vertices, 1,4 and 7,2, as it is given in the question. With that known, what we can do is we can tabulate what our steps are going to be to find the vertices of the square. That means vertices B and D, and also the equation of the diagonals. So the first step would be to find the midpoint. The midpoint here is what I refer to as this point, O, is the point at which both the diagonals BD and AC intersect. And since this is a square, that is, all the internal angles, something like this, and this, as well as this, are at 90 degrees. Therefore, the diagonals are not only equal to one another, that is, BD is not only equal to AC, they are also perpendicular. So this angle here is 90, and so is this as well. And like any other parallelogram, the diagonals are also bisected by each other. That is to say that this length here is equal to this length, and so is this length equal to this, or equal to this as well. So all the four diagonals are also divided into two by each other, and there's a whole lot of symmetry in this case. So using that, we can find out the midpoint of the diagonal AB, because if we know the midpoint of diagonals AC, then we know that the diagonal BD also passes through that point O. So we now have one key information that the diagonal BD passes through the point O, with which of which we know the coordinates. The second thing would be then to find the equation of the diagonals. So if we know a point through which a line passes, the only other thing we need to know in order to write down the equation of the line, and the line I'm talking here about is BD, is the slope. So we know our point O just by the coordinates of A and C. Now we need to know the slope of the line BD. To find that, we will employ our relation m1, m2 equals -1. That is, if two lines are perpendicular to each other and they have the slope m1 and m2, then if we know one of the slopes, say m1, then m2 turns out to be -1 times m1. That is -1 times the slope of the line which is perpendicular to the line that we are looking for. So for BD, we need to know the slope of AD and then take the negative inverse of that to get the slope of BD. Once we know that, that is the slope and the coordinates of O, we will now know the equation of the diagonals. But now the only task that's left is to find out the location of the point B and D. And in order to do that, we must employ a relation which is a quintessential property of a square. That is, this distance here must be equal to this distance, and so must this distance be equal to this. That means if you're looking for a point BD, which lies on the line, looking for a point B, which lies on the line BD, then we will choose its coordinates such that A, it lies on the line BD, and B, it's at equal distance from C and A. And not only equal distance, it's also at a defined distance from A and C. And that distance is something that we can calculate just by knowing the length of the diagonal, which we can also figure out. So there are a whole lot of steps in this, and I've jotted them down in 3 key steps, and we will try to work them out in that manner. So let me just get rid of most of the right pair, and let's begin with the first thing. The first thing was to find the midpoint of O. So the coordinates of O would be, which is the midpoint, would be given by, well, 1 plus 7 by 2, comma, 4 plus 6 by 2. And why do I do that? Because if the points of the ends of the line segments are known, the coordinates of the line segments are known, then we can figure out the location of the midpoint, which is just the average of the x-coordinates and that of the y-coordinates. So using that relation, we have 1 plus 7 is 8, divided by 2 is 4, and 4 plus 6 is 4 plus 2, I'm so sorry, it's 4 plus 2 here, because I take 4 from C and 2 from A. 4 plus 2 is 6, and that divided by 2 is 3. So the location of the midpoint, that is the location of O, is 4,3. So we have the location of this point as 4,3. So that's the first step done. Let me just erase this now that we know the information of point O. Now let us try to find out the slope of BD. What do we know about the slope of BD? Well, we know that BD is perpendicular to AC. Therefore, the slope of BD must be equal to -1 times the slope of AC. So, what would the slope of AC be? It's very simple. If we know that the line passes through 2 points, 1,4 and 7,2, that the slope is just defined by the difference in the y-coordinates. Let me take 4 minus 2 in that order, and in the denominator, that would be the difference in the x-coordinates. So that would be 1 minus 7. So that would give me, well, 4 minus 2 is 2, and 1 minus 7 is minus 6. That would be minus 1 over 3. Therefore, slope of BD would be -1 divided by -1 by 3. Cancel, cancel. 3 goes to the numerator, and we're left with 3. Therefore, the slope is 3. We know the point through which it passes, and now we also know the slope. And the only thing that's left to do is to find the equation of BD. And using the form of 1 minus y1 equals the slope times x minus x1, we can employ that relation to get the equation of line BD as y minus the y-coordinate of the point through which it passes, which is 3, and the slope, which is 3, times x minus the x-coordinate through which it passes, which is x minus 4. Simple as that. We can further simplify this to get y minus 3 equals, well, 3x minus 3 times 4 is 12. We can add 3 on both the sides to give y equals 3x minus 9. So that is the equation of BD. So now the equation of BD is known to us. Let me just write that like so. So this is a diagonal. Then the equation of BD is y equals 3x minus 9. So that's there. Now we know all the information. We can get rid of this to make room for our next calculation, that is to locate the points of B and D. So what is the key information, characteristic rather, of the point B? Well, B happens to be at the same distance as it is from A and C. But what is that distance? If we know that distance, then that would be really nice, because we can equate the distance between B and A to the particular distance that we anticipate it to be, and then locate the coordinates of point B. What I'm talking about here is the fact that, as we know, the length of the diagonal, length of CA is known, which should be difference in the y-coordinate square, which is 4 minus 2 square, plus 1 minus 7 square. We can add them up to give, 2 square, because 4 minus 2 is 2, plus 6 square, because this is 1 minus 7 is -6, -6 square is same as +6 square. We can simplify this further on to get 4 from 2 square and 36 from 6 square. This yields root of 40, which is same as 2 root 10, which is same as 2 root 5 root 2, because 10 is 5 times 2. So I get a form like this. Now that we know that the length of AC is 2 root 5 times root 2, and there's a reason why I write it like this, which I'll explain right now. So, now that we know that the length of AC is so, we can actually work out the length of AB. Because if you look at triangle ABC, we know that AC square equals CB square plus BA square. And why is that? Because that's the Pythagoras theorem. Because this is a right angle triangle right there. Therefore, we have this relation, the hypotenuse square equals the sum of the squares of the perpendicular sides. We know AC square is, well, the square of this term. So we know this part of the equation. What about CB and BA? CB and BA, as I've already said, are the sides of the square. And as the sides of the square are equal, if I call this the side D, like so, then I would have AC square should be equal to D square as the length of CB, and BA, which is also D square. By writing them as a common variable, what I'm doing is I'm equating the lengths. I'm saying CB equals to BA. I can add them up as 2D square, and that would be equal to AC square. Now, I'm using this information to write AC square in terms of the numbers that I've figured it out to be. That would be, well, we know that this is nothing but root of 40 from my previous calculation. Therefore, root of 40 square would be basically 40, and that should be equal to 2D square. Therefore, D square would be equal to 20. That means D should be equal to root of 20, or the sides of the square would be equal to root of 20. That means this is the length of the side of the square. So, at this point, we know that the length of the sides of the square is root of 20, and we are getting more and more information just by knowing the endpoints of one of the diagonals. So this is good. What we have employed here is just the Pythagoras theorem and the fact that the sides of the square are same. Once we've also noted that information, we can get rid of this and make room for some more calculations. Right, so we know that B and D lie on the line y equals 3x minus 9. So, if I have to write down the coordinates of point B as x, y, then my x, y should be something in which the y is related to x by this relation. That means the coordinates of this point should now be not x, y, but some x, 3x minus 9. What I've done is I've just substituted y as my relation of the line, because B and D lie on the same line. What I'm doing here is I'm locating a random point on the line, which is related by this relation. So, any point lying on the line BD would have this form. Let me assume that we choose that particular x which satisfies the coordinates for B. That means let's assume that B lies on x, 3x minus 9 for some x. At this point, we don't know what x is. X could be anything, but let's assume B has this form. Right? We can make that assumption just by knowing that B, like D, lies on the line y equals 3x minus 9. Now what can we do? We can equate the distance of BA square to be the side square. And now that we know the length of the side, well, this would be root of 20 square, or just 20. So, changing my pen once again, what I can do at this point is that, let me assume that B is of this form, then the length BA would be, if A is 7,2, then the length of BA would be the square of the root of 7 minus the x-coordinate of B. 7 is the x-coordinate of A minus the x-coordinate of B square, plus the difference in the y-coordinate. So y-coordinate of A is 2, and the y-coordinate of B is 3x minus 9, but the minus 9 should become a plus 9 because we're subtracting it. That square must be equal to 20. So at this point, we know that this, oh sorry, I missed out a square there. So at this point we know that this relation would give us some value for x. So we can solve for x using this. That means we will get a specific point, a specific x, and that specific x would give us the x-coordinate of b, and this relation will give us the y-coordinate of point b. So we can solve this further on, and we realize a subtlety here. So squaring an under root is same as just getting rid of it. What we can do is we would get 7 minus x squared plus 11 minus 3x, like so, whole square equals, well, 20. We can simplify this and expand the brackets as follows. So 7 squared is 49 plus x squared minus 2 times 7 times x, same as this. This would be 11 squared, which is 121, plus 3x whole square, which is 9x squared, minus 2 times 3 times 11 times x should be equal to 20. Getting rid of things which are on top a little bit, all we need to do is simplify this. We are left with just that. So adding on the constants, well, we have 121 plus 149 and a negative 20 from this side. I'm going to bring it to the left hand side. That will be 49 plus 121 minus 20 plus now the coefficients of x. So I take x out as a common, and well, I get negative 14 from this term. 7 times 2 is 14, but the negative sign makes it negative 14, and same as this. So this is 2 times 3, which is 6, times 11, which is 66. And there's also a negative sign there, so that should be negative 66. Now the x squared term. The x squared term is simple. This is an x squared term from here and an x squared term from there. So we have the coefficients of 1 from here and a coefficient of 9 from there. That is equal to 0. Why? Because we took the 20 to the left-hand side. We can simplify this once more to get x squared times 10 plus x times, we get a 10 because 9 plus 1 is 10, and 66 plus 14 is, well, we can add 4 first to make that 70, and we can add 10, the remaining 10 to make it 80. So this is 80, but with a negative sign because we were adding them in the negatives, plus the constants. So the constants would now add up to be, well, 121 plus 49 would be, we can add the 9 first to make them 130, and 130 plus 40 is 170, and 170 minus 20 is 150, like so. That is equal to 0. So we're getting to our answer now. What we can do at this point is divide the entire equation by 10 to get rid of the coefficients, and we're left with x squared minus 8x plus 15 equals 0. If you simplify this, you can expand this as x squared minus 3x minus 5x plus 15 equals 0. You can take x common out of this. The first two terms to give you x minus 3. You can take negative 5 common out of this to give x minus 3 from the last two terms to give you 0. You can take x minus 3 common out from the first two terms now, first term being this and the second term being that, and multiply that by x minus 5, whatever remains. So we have now simplified our relation as so. Therefore, if this is our, well, equation, then two factors give you 0. That means either one or both of these factors are 0. That means x can be 3 or 5. And the reason I say that is because x minus 3 can be 0 or x minus 5 can be 0. And if I add 3 to this and if I add 5 to this, I would give these two relations. That means x can be 3 or 5. Alright, therefore, if we equate a random point on this line, BD, and we say that that point is at a distance of root of 20 from A, then we get 2 points, and rightly so. We get two values of x. That means our x could be 3 or x could be 5. And this means that we actually get 2 points. And we get 2 points because if you want to be at a particular distance from a line, you can actually have 2 points, B and D. which are equidistant from point A, and that comes from the property of a square. Therefore, either of B or D would have the coordinates, x coordinates as 3 and 5. Now, what about the y coordinates? Because our ultimate aim here is to find out the x and the y coordinates at the point B and D. So for point B or D, the x coordinates is, 3 or 5. If it were 3, then the y coordinates would be using this relation. Because remember, the points B and D always lie on the line of y equals 3x minus 9. Therefore, if we know the x coordinates, we immediately get the y coordinates using the relation. Therefore, the y coordinates would be, 3 times 3 minus 9, which should be, 0, because 3 times 3 is 9, so this is 0. So the first point would be 3, 0 at the first vertex, and the second point would be 5 times 3 minus 9, again employing the same relation as this. This would be 15 minus 9, and that should be, 6. So the second point should be 5, 6. We now know that if AC are the opposite vertices of the square, and they are given, then we can immediately find out the location of the points B and of D. And just by looking at the diagram, we would know that, 3, 0 is something which lies on the x-axis, and that would denote the point D, as how I have drawn it here. It is close to the x-axis and not exactly on the x-axis because, I did not draw the diagram to scale, so it's close enough but not rightly on the x-axis where it should have been. What about point B? Well, point B is far away from the x and the y-axis, therefore this can denote the point B. So just by knowing the information that A and C are 1, 4 and 7, 2, we know the coordinates of the other set of opposite vertices of the square. If we want to further check whether our solution is right, what we can do is we can employ the same property that we did in the first step of our solution. If BD forms the line segment that denotes the diagonal of the square ABCD, then the midpoint of BD must be O, which is 4, 3. Let's check if that's the case. So if BD is 3, 0 and 5, 6, therefore the midpoint would be 3 plus 5 by 2 and 0 plus 6 by 2. If you simplify this, you get 3 plus 5 is 8, and 8 by 2 is 4, and 0 plus 6 is 0, and 6 by 2, 0 plus 6 is 6, I'm so sorry, and 6 by 2 is 3, which is the same as what we got just by finding the midpoint of the line segment AC. So indeed, this matches the form as the line segment AC. And you may be wondering why I did not find the equation of the line segment AC. But if you really think about it, it's very simple. You know the 2 points, and you can employ the form y minus y1 equals the slope as y1 minus y2 upon x1 minus x2 times x minus x1. So simple as that. You can employ this, you can use this relation to find the equation of line segment AC, and I leave that up to you. So good luck with that, and I hope this video made sense and clarified a lot of ways in which we can employ the rules of coordinate geometry to answer key points for a question like such.